pursuing MTech degree at IIIT Hyderabad. I feel honored to extend my warm welcome to all present here. On behalf of IIIT Hyderabad student chapter at Earthquake Engineering Research Center, I want to take this opportunity to welcome our honorable guest, all the faculties, industry people, participants from the academia, research fraternity, and all the students to join the webinar on an advanced topic, Futuristic Construction Chemicals for a rapid growing construction industry. Today, we have a privilege to have with us an expert in this field of building construction materials who shall be reflecting on the theme of this webinar. Now, I would like to introduce our keynote speaker for the day, Dr. Muralidhar Kamath, to our esteemed audience. Dr. Muralidhar is presently working as a General Manager Technical Services in Apple Chemie India Private Limited, Nagpur, Maharashtra. He is highly skilled in FESM, EDS, XRD, FTIR, TGA, NMR, thermodynamics, and hydration modeling. Also, machine learning, high score, Origin Pro, and Minitab. Strong educational professional with a PhD focused on microstructure of alkali activated concrete. He is working with various research institutes like IIT Bombay, CBRI, L&T, VNIT, and John Morris University, Liverpool. He is having 2 patents on his name. He published number of research publications in the national and international journals and conference proceedings. He is involved with various research and publication work of MTech and PhD students that cater the need of construction. This is a brief introduction of our keynote speaker, Dr. Muralidhar Kamath. Now, before we start the event, a small announcement to all the participants. If you have any questions, doubts, or clarifications, please do type your queries in the chat box only. We will have a sufficient time for the discussion at the end, where Dr. P. Praveen Kumar Venkatrao, Faculty Advisor of Student Chapter, will be the moderator. Now, without any further ado, we will turn the time over to Dr. Muralidhar. Sir, over to you, sir.
Yes, I think thank you, Lakshmi. And also, I like to extend my thanks to Professor Praveen and IIIT Hyderabad and I think I Structure. And, uh, and thank you for allowing me to present about our futuristic construction chemicals for our rapid growing construction industry. So I'll jump to directly to topic and please let me know कि my screen is visible to you and I am audible.
Yes, your screen is
Yes.
visible and you're perfectly audible.
Yes, thank you. So, futuristic construction chemicals for rapidly growing construction industry. As maybe you can see in my introduction abstract, what been there, what we are talking now. It's not about Burj Khalifa. Burj Khalifa, we already been to 1 kilometer. Now it's about they are targeting about tall buildings around 2 kilometers itself in Dubai, and it's been planned and it's going to come up. And so like that I'm saying ki mass construction, there is a city, neom city is also going to build, that is horizontal, totally a city is coming over there. So nowadays what we are talking about is something different, and it's not about only you can achieve with your conventional materials. So due to that you require chemicals over there to use. So due to that, and I'll start with little bit of our company introduction too, and but that will be content, company introduction, wise, innovative, key products, new product developments, and how we are in this. We are going to use in our construction process. I'll introduce you about, because I being to means it will be the mix of your construction industry and the research. So how we are going to, so it's about Apple Chemie. It's been like the uh, and also an Indigo paint subsidiary company, and it's been from past 30 years, and we are providing the range of construction chemicals like waterproofing adhesives, sealants, grout, concrete additives, coatings, and many more. And why, what is Apple Chemie? India's only concrete tech company, manufactures more than 150 products, 25 years of experience, geographically center of India, and first manufacturer of PCE. What is PCE? Is over here polycarboxylic based ether, and that's we bought the plant first time in India, and we are having the presence in pan India basis too. And why is innovative? First, polycarboxylic based ether, then AC crystacrete, that is crystalline durability enhancing admixture. I'll going to elaborate more about crystacrete, and it is available in Bulker and 6 patents. So these are the patents, and I'll be quick over here. Okay, and this is patent granted. And this is the pilot plant. Okay, whenever we are going for a polycarboxylic based ether, okay, so that you generally maybe the name with super plasticizer or plasticizer in your books. So that is the base will be, there are types of base. I'll come and explain about the bases, but in the admixture part that is going to come. Okay, that time you can see over there how what is PCE and how we are saying it a base. So these are the pilot plant. This is our R&D facility. It is in Nagpur. This is in Mumbai. And I'll start with the crystalline admixture because I don't want to waste that much of time. It's been you can see in the internet too. So what is crystalline admixture? So what is crystalline admixture over here? It is the integral crystalline waterproofing technology. Okay, in a concrete, whenever we are saying there are two types of thing as per classification of ACI 212. Okay, what 212 says, it is mentioned in 2123R chapter 15. Okay, chapter 15, you can check the crystalline durability enhancing admixture. Okay, so whenever we are saying it is the permeability reducing admixture, and whenever you are going to add in a concrete, so generally it will be the range from 0.8 to 1% depending upon the manufacturers. Okay, generally the crystalline durability enhancing admixtures, what it do, it will be present in the concrete, but it will not dissolve at the time of reaction. Means when you are adding water in your concrete, okay, that time it is not going to react. It will be there in the presence of in your concrete throughout your life. And whenever the moisture will be in a contact with them, that time this crystal will form, and it will self heal automatically. So you can see the projects like expressway, Samriddhi Expressway, your Delhi Mumbai Expressway. These all expressways are, in their specification, we have to add this crystalline admixture over there to enhance the life of span of the structure. Similarly, if you know the bullet train specification, if you will check that, in that also you have to require to add this crystalline durability enhancing admixture. So this is one of the product we are also supplying. Okay, so the it is again the cementitious product is there, and it will plug your pores, capillary tracts and micro cracks will also be reduced, and that will block the entrance of water. What is the entrance? And due to crystal formation, see, let it be your chemical attack, let it be your water in the coastal areas, or let it be your environmental condition wherever your concrete is exposed to, right? That time whenever your concrete is getting deteriorated, it will be like it will go through the cracks or pores only. That is means transport, we'll call it as a transport property. It's a new term, maybe you have to find out what is the transport properties of concrete. Okay, because these all are carbonation, your air, your moisture will get transferred from inside the concrete, and then it will create a problem. Due to that, this is the crystalline durability enhancing admixture is added. Okay, and this is ISO patented technology. In this also, if we are going to add this in your concrete, so here you can see the fourth picture over here above. C certificate, C is the European certificate. Okay, in that what will happen, it will be, let's say if you are added in a concrete, okay, this material, okay, you have to wear the x-ray glasses, and you have to scan the concrete because they are added it or not, because of the quality purpose it given the fluorescent uh, color over there. So you can check in the concrete for the quality purpose. Okay, crystalline admixture is present over here, it will self heal and give the durability to your project. These are the testing facility. You have to do the Marshall Kuhn test, that is for your compatibility with the cement. Okay, because the crystalline, when you are adding, so the main component will be their cement or cementitious component, so you have to check the compatibility of crystalline durability enhancing admixture, then sulfate resistance test, then rapid chloride. Sulfate resistance, it is going to be your chemical attack, right? And rapid chloride penetration is going to, the chloride penetration at as per your ASTM 102 12102, that is the latest code is 2019. Okay, so from that you have to check, and we will pass the ions. I'm going to explain a little bit further this experiment too. And then self-healing test, this is going to be a lab test. Then mortar permeability, maybe many people are not aware of the mortar permeability. See, at last, whenever you are going to test the crystalline durability enhancing admixture, see the water or any your ingress chemicals or uh, whatever the environmental condition is over outside, it is not going to travel through your aggregate, it is going to travel through your mortar phase only. So due to that, the mortar permeability is there. Okay, and then concrete permeability, again concrete permeability, there are two tests. Okay, I'm going to explain in detail. That is depth of penetration we will check, and then we will check of coefficient of permeability. Both are different. Okay, that require four cycle, and the water permeability require only one cycle. Then your chloride diffusion test, shrinkage test, RCPT, these are all required tests. Testing of it's been like from various authorities to check it, because you have to believe on third party. If I am saying ki my material is good, it's not like that. Crystalline durability enhancing admixture, we have to get it check through many various authorities, third party. Then what's the difference between integral crystalline waterproofing and your crystalline what integral? There are, in the market there are terms are there, integral waterproofing and integral crystalline waterproofing is there. So integral waterproofing is IS 2645, it adheres to IS 2645. And integral crystalline waterproofing is, it is the part of your concrete, so it is adheres to 2123R10 chapter 15, as I already said. Here it is not going to block your micropores, but in crystalline it is going to micropore, and it resists hydrostatic pressure. If in the piling also, in Mumbai region or in any place, wherever the coastal regions are there, let's say Chennai or your Mumbai, so wherever the Vishakhapatnam, let it be any coastal region, if they are doing the piling or any of your in that region, if they are going for piling up to 200 meter, 100 meter, that time for the concrete piles, okay, they need to add they need to check with the 16 bar water pressure. 16 bar, not the 5 bar. The regular water permeability is of 5 bar water pressure, but in the case of pile condition, they require to 16 bar. At that time also this crystalline needs to add. So that's what the advancement of the construction. It's not only about cement and micro materials we are going to add nowadays. The crystalline products they are using, and it's been and again the hairline crack gets healed, life of structure get increased. How it is going to increase, that also I'm going to show you. And it is available in bulker. Then the relation between durability versus permeability of concrete. Whenever durability means, what is durability over here? What durability of concrete means? The ability to resist weathering actions, chemical attack, and abrasion while maintaining its desired engineering properties. Means whatever the compressive strength of flexural or whatever you can say mechanical properties are there, it should not be changed. Okay, if I am going to add this crystalline material, and see, as a designer, whenever you are going to design, let's say from IS 10262 you are going to do design, that's also from 2019 I think updated. So if you are going to check over there from design service life, so what is the thing? Your mean strength is equal to Fm is equal to Fck plus 1.65 into S. S is for standard deviation. If we will check this overall equation, there is no thing called T. There is no time, right? So we are not designing our concrete for any time. We are saying it is going to withstand 40 years, 50 years, 100 years. We are saying it, but we are not using in our design. and we are saying ki design service life will be 50 years, but when we are checking with the permeability, okay, so the latest code is going to develop. And I think I met in one of the conference Manu Santanam, a professor from IIT Madras, okay, and we are having a discussion over there. That time we I discussed this thing. So he told me ki the latest code is going to be performance based concrete admixture, performance based concrete mix design, okay, performance based concrete mix design. It is not going to be only mix design. So again, if you see design service life, but actual service life, it is going to be 40 years, or let's say 45. So another 10 or 15 years what we are claiming, we can't claim. So in this particular thing, you can, it will help the crystalline durability and enhancing admixture you can add, or you can add any crystalline product which is going to increase this chemical attack and increase your service life. Then projected concrete service life I given here, M1 mix, okay, this is of grade M30. The second one M2 mix of grade M40, okay. So above M40 or M50, okay, so above M40 or M50, the cementitious content is going to increase. So whenever you are going to add a crystalline in M30 grade of concrete, its service life gets twofold. So twofold means if it is going to serve for 40 years, then it is going to serve from 80 to 90 years, because of it is not going to for your it is going to withstand against your weathering actions and chemical attacks. So, and it is according to fixed law we studied over here. Then these are the crystalline solution for concrete coating. There are coatings are there. Crystal seal will be there. Sealing, we will do the seal. Seal means if there is going to be you have to seal your particular concrete surface, so we can seal it. Then crystal shake, generally when you are going to for a DPC foundations, when we'll do where there will be excavation, then over your, after your, just before your DPC means damp proofing course, okay, we will do at a foundation level. Before that we will do the dry shake. Dry shake powder will pour, because of water should not come in the DPC or your foundation from the below capillary action, so we'll protect over there. Then crystal mortar, sometimes mortar also you have to require over there with the your that is the repair material. Plug, one of the site I'll say, I've been in Shapurji, Palonji, Mumbai side, that is of BDD Chawl. It is going on, I think, around 40 floor building. So they already, they excavated up to 18-meter below. Okay, and what happens, because the water table is very high in Mumbai. So after the shore piling also means they are giving the retention wall to your soil just after that, because we can't move soil because of vicinity there are buildings are there, so you can't move it out from there. So there this crystal plug is there, just it is in a powder, okay, where from wherever the water is coming we have to put and we have to block that. But it is the temporary solution. The permanent, always remember, you have to give the water away. Whenever you will give the water to away, means if you will give him away, it will go somewhere else. It is not going to create a pressure to your foundation, okay, and prob. Then crista injecto, wherever the cracks will be there, okay. uh, it is repair and rehabilitation work. Like if the concrete PQC road surface, you will find out the cracks after the 28 days. So that they have to, because of maintenance purpose and checking, their bill cannot be passed. So that time they will, they have to fill all the cracks properly for durability purpose, increase the service life. And we have, there are approval authorities are there. I think it is not right now. We have to get approvals at, I am saying, from the industrial part. Then we have to go with all the approvals, then only we can give this crystacrate. Or then the application method of crystacrate, how it is going to use, there will be, nowadays we are using only ready mix concrete plant, so you can add directly in the RMC it is in 25 kg, you can add over there also, you can add inside also. Okay, then you can apply from the surface coating, then sealing of cracks and heel. Dry shake I already explained recently. These are the surface preparations. But now to make the means, what are the advantages? Here you can see this is a at the below there are the cracks of 2 ml. This is after crack and before cracking, you can see. And it reduces, it can heal up to 0.5 of crack healing. As you can see, this is the test we are doing in our this is again means I did again few of the lab developed test I developed. I connected it with pumps and I supplying the continuous head of the water throughout. I am keeping it and I am understanding and cracking of your concrete cube of 150, splitting it, then creating watertight and keeping that water pressure over there. And if it is not getting self fill, water will pass. If it is getting self fill, water will not pass, like that. And then it should have the coefficient of permeability more than 90%. Chloride diffusion should be around 45%, like that. And shrinkage should be reduced by there will be shrinkage about more than 20%. Allows concrete to breathe, protect. If it will be the integral part of the concrete, it is going to protect your steel bar from the corrosion. And I'm going to speak little bit more about corrosion, we'll talk about it. And it's against effective resistance, I already told. Now if I'm adding crystalline product in our concrete, so if I'm adding, so I need to test it. And what are the testing parameter? So the specification always says ki how we are going to test it and what will be the parameter. So rapid chloride penetration test, water penetration test, and self-filling capacity. Okay, these are the tests. Now here you can see the water penetration test. It is as per DIN 1048 part 5. Now if you are going to see this particular fixing screw and test specimen are kept under the water pressure of 5 bar. 5 bar I am saying water pressure will keep, and we will give the we will keep at a 5 bar, and we will keep it for 72 hours water permeability test. And after 72 hours up to 48 hours, we will keep it in a drying cycle. Means that water level we will remove, and this particular cube will be at a drying period. It will get dry, and then we will split it. Okay, and we'll check the impression of our water in the concrete surface after the splitting, and we'll mark it, right? When this is one cycle, this is one cycle where you are checking the depth of penetration. But what is the coefficient of permeability? You are going to cast two cubes, one with crystallite mixed design and another without crystallite mixed design, means crystalline mix and without crystalline mix. Okay, and three cubes you will cast at a time. You will keep it for cycles. There will be 4 cycles, 72 hours of water pressure, then 48 hours of drying cycle. This is one cycle. Then again you will repeat 72 hours of water pressure, 48 hours of drying period. Similarly, third cycle, fourth cycle. After fourth cycle, okay, you are going to check the permeability K as per Darcy's law or Valentas equation. Okay, as per Darcy's laws or Valentas equation, you are going to find out the coefficient of permeability with crystallite, and without crystallite you will have K1, you will have K2 value. So K1 minus K2 divided by K2 into 100, you are going to find out the coefficient of permeability in percentage. And generally it will be in the range of coefficient of permeability 10 raised to power minus 13 to 14, you will generally find out. And it is going to reduce from minus 14 to 13, or it is going to reduce with the crystalline product. Again, the rapid chloride penetration test, if you are going to do as per ASTM, they given charge they given this chloride permeability. So in the one cell, you will find out this is the anode and cathode system only, very basic system. If you are going to say, we are going to supply the 60-volt of power supply. Okay, over there you can find out coulombs in the, we will get the reading in coulombs. And this you will see both the cells. One is having sodium hydroxide of 0.3 molar reservoir, another is having of 3% that salt solution sodium chloride reservoir, and you will cast your sample of 50 long and 100 diameter with the top surface facing to your sodium chloride solution of salt solution. And then you are going to check with this our apparatus, and where we are passing the charges, right? As you can see in the images, it's visible. Okay, then you will check the readings. If you are going to make, let's say, M30 grade of concrete with and without crystacrete, okay, with crystacrete, if you are going 2000 to 4000, if your M30 is giving without crystacrete, when you are adding the crystalline admixture, it will come from moderate to low or very low region, means 1000 coulombs to 2000 also can come, or 100 to 1000 coulombs also can be come. And I am saying, recently, if as the bullet trains are going to come up from Ahmedabad to Mumbai, in their specification they mentioned the concrete should be, the RCPT value should be in a very low range from 100 to they are asking to negligible range. At that time you have to require the advanced chemical, where this particular, because they are targeting about the age of the concrete. They are trying to build it from 100 to 150 years of the structure. Due to that, they are using this type of material over there. Again, these are the, as I tell here, you can see this is my self-developed method in the lab. And over there you can see I connected it the pump, and then I make it watertight, then I'm supplying the water like in a cooler we do. It's very, very basic. And I developed the crack over here, pre-crack. As you can see, this is the flow with the time. Generally it will take from 50 to 90 days period to self heal the crack. And you can see the insoluble crystal were found to seal the crack of opening of 0.5 And as you can see the sample preparation, here we are measuring the flow rate in liter per hour. So liter per hour we are measuring. If it is going to zero, means the water whatever getting passed over here getting self healed over there, and wherever the water supply is going on through the cracks, means that is not get healed, right? So it is like that. The experiment is just a self development method area to use, where you are generally, I told, in the foundation level. As here you can see in the this particular image, there sure piles are there at the foundation levels, right? And then precast girders, shotcrete, swimming pools, water retaining structures, aquarium, retaining walls, sewage and water treatment plants, underground vaults, elevator shafts, dams and reservoir. And already we supplied to Nagpur, Mumbai, super communication expressway, Delhi Metro, Thane Creek. Recently it is going on Thane Creek Bridge, that is going to be constructed by L&T, as I've been visited and I'm working with them. And then Sitco housing project is a mass housing project, and they are, it's a, I've been to BG Shirke is one of the client of ours over there. They are casting like precast yard is there. You can't assume how much of concrete is going on. I've been there for a month also for some of the their technical issues over there, to resolve that issues. I've been over there for a month. So the daily concreting is 1500 meter cube per day. So that amount of concrete and that amount of panel they are casting like machines, they are casting. It's been a good project of Sitco is going on Taloja. And one more example I like to quote over here, L&T delivered one of the recent project, and we are involved in that project. 75 days, 75 flats. This is the rapid construction industry what I'm talking about. L&T did in Mumbai. That also maybe you read in you can search in YouTube, it is available. And Chhatrapati Maharaj International Airport, Versova Bandra Sea Link, BBSL. I talk about this our clients. This IRC also mentioned about crystalline durability enhancing admixture. That's what I'm talking about. I comes to, like I told you about I explained you about our crystalline durability enhancing admixture. I'm coming to admixture. What admixtures? Why we are going to use admixture? As you know, Yes, we are going for rapid construction industry. We are casting volume of concrete batches are going to create. So 6 meter cube of concrete RMC your transit mixer can carry from one place to another, right, from RMC plant. But it require, let's say, after 2 hours it will reach site. After 3 hours it will reach site. So depending upon the conditions we supply it, right. So generally, polymer based additives will be your plasticizer and super plasticizer. What will be the types of polymer? See, the first generation types of polyplasticizer is lignosulfonate. Then the second generation is your sulfonate melamine formaldehyde. These are the base. It is the base of your plasticizer and super plasticizer. Then your sulfonated naphtha formaldehyde. This is again the second generation, and this is the latest. The third SNF is third. Then this is the fourth generation is polycarboxylic based ether. I told you about already when we are started with our presentation. And influencing factor over here, because see, ls, if you are saying ls, ligno sulfo, ligno I'll call it as, okay, in a short, if you are going for a ligno base only, you can go with 1 hour or maximum. There will not be any. Nowadays everyone is asking for self compacting concrete or free flow concrete, pumpable concrete, like that they are asking at the industry level. So you can't go with the ls like that. SMF is also not compatible, because there will be, they are using 3 to 4 types of brand of cement, and maybe sometimes 43, maybe sometimes 53, again source of aggregate, source of cement, source of you know all the your source of whatever the material you are using, it's changing totally. So again you require great compatibility over there with your admixtures. Then sulfonated naphtha formaldehyde you can use, not in every places. Again, from that you can go with the SCC, you can do, but the admixture percentage, the chemical required will be more over there. Then the PC you can go with one from zero point 0.5 to 1.5, depending upon your aggregate. You can, or your design and your grade of concrete, you can go with the PCE. And dosage of plasticizer also influencing factor over here. Then it can affect your setting time, it can affect your workability of concrete, it can affect your mechanical properties, and if it is going to be a higher grade of concrete, then for sure the microstructure. And the plasticizers are, as I can say, these are the chemical compounds of, it going to reduce your, generally whenever you are going to use, so generally it will be reducing your water percentage. Means, see, there is a water cement ratio is directly proportional to concrete, or I can say directly water is directly proportional to your concrete compressive strength, right? So if I am going to reduce, definitely your concrete compressive strength is going to increase. So this helps over there, and it makes concrete denser. And generally plasticizer and super plasticizer can be, nowadays we add from zero point 0.1, zero point 0.5 to 1.5 range. Many people ask me, can't we go above 1.5? I'll give the example always. Okmayo self compacting developed in 1980s. So he started with the 6% of added chemicals over that time. So you can add, it's not like that you can't add above 1.5% of chemicals. Depending upon your need, you can add that. And plasticizers, generally lignosulfonate is a natural polymer, that is we call it as plasticizer. Super plasticizer will be SNF and SMF and PC. I like to add over here, nowadays whatever you are buying, let it be from any other competitor like Fosrox, BSF, or Apple Chemie. So we are now giving you a product in that there will be air entertaining agent will be there. In that only there will be deformer. Generally we use it for silt content, wherever the silt content is high, because nowadays we are not using any natural sands. Okay, we are using crushed sand. So crushed sand, when we are using, the silt content will be from your 15 to 20%. It is restricted to 15%, but sites will not be like that, it will be 20-25%. So we have to use deformers for silt. Then your VMA, viscosity modifying agent. VMA also we'll say, okay, viscosity enhancing admixtures also we say it. and then your this PCE basis will be there for water reduction, or one more will be there, slump retention will be there. Slump means after 3 hours you have to make it retention of 100 slump, 200 slump, or free flow concrete. For that we require to add this type of admixture over there. Then admixture will be, the range will be generally of PC will be low, mid and high range, depending upon your requirement of slump and mechanical properties or compressive strength requirement. Because nowadays I said precast industry is asking 10 hours strength. After 10 hours they require 15 MPa or 20 MPa because of lifting strength. They are going to lift the precast panels, so due to that their requirement is like that. And SNF will be low and high, there's not called mid range over there. Then I'll come to your curing compound and protection coatings. Over here again, curing compound and protection coating, as you added your admixture and your concrete, but after that there will be evaporation losses, and you required over there full hydration of your cement over to achieve your full compressive strength. Now again, we are nowadays thinking more about sustainability and environment parameters, and over there we are not going to use the water over there. We are applying this curing compound. Yes, there will be environmental few parameters, maybe in production there will be impact, but water is going to save over here. So evaporation losses we are, and it also helps in your reduce the shrinkage of cracks over there. And there are curing compound, resin based, wax based, water based. It's very, I'll explain to you in a very simple thing. Whenever you are using this type of compound, you have to ask your applicators or whoever the contractor or construction peoples are there, are you going to paint, are you going to use any putty or whatever the surface, like in a building or your metro project or your bridges. Okay, depending upon that what they are going to do, because above resin and wax based you can't paint or you can't do anything. Okay, so that time water based is suggested. Generally in your housing sector we generally suggest a water based curing compound. Okay, these are the curing compound. Okay, resin based, then your aluminized reflective is also there, water based, wax based. Generally I said wax based is generally used for your road and canals. Okay, your irrigation projects, there will be canals where they will be used. And coverage and all, curing efficiency, generally we'll check the curing efficiency, and drying time should be less than 4 hours. Okay, and if you are seeing the various effects on the curing practice on the strength, you can see in the laboratory air time it's less strength than in air. After 7 days of moist curing, if we are going, the strength is comparatively 4-5 MPa more. Again, when in a air after 28 days of moist curing, then again it is the strength is gaining over there. But moist cured entire time means throughout the time if we are curing, okay, so it is gaining again above 50 MPa, means after 365 days when we are checking over here. Okay, these tests are saying about that. And what are the properties of curing compound? See, curing compound whenever you are going to apply, that depends upon water retention, and it should be conducted as per C156. Then reflectance is the again the one thing where you are going to check the daylight reflectance after applying your curing compound. And when should apply you curing compound, that will be a question to you. I'll explain to you case by case. Okay, just maybe I explained it, I'll check. If not, I'll going to explain that. Drying time, the test should be conducted as per ASTM C309, class number 10.3. Then long term for routine, this is the routine test. Okay, setting we will check, but generally we'll check it should be less than 4 hours. It should be tacky, just you will check it is tacky, then fine. Non-volatile content. Then there are curing methods, if you know, in the concrete: immersion, ponding, steam curing, wet gunny bags, membrane curing, then curing compound. So curing compound, whenever you are going to, you can use in all the structures: PQC pavement, structural members, column, beams, canal lining, runways, bridges, decks, etc. Okay, what we'll check generally, the evaporation losses should not, the water retention we will check should be 0.5 kg per meter square in 3 days. The reflectance should be 60% more than efficiency, means curing efficiency. And what you will do over here, you will cast the cube. One will be with curing compound, one will be inside your water tank. Your normal curing in the lab will apply the curing compound like a paint over the cube, and we will keep, and it should dry less than, and it should be after 12 hours. It should not be tacky, like we will check it, and it should be as per ASTM C03309 and 156. The curing efficiency, see, at the first day when you are going to check, the evaporation losses over the curing efficiency will be high like a water, it will be. Then after your 72 hours when you are going to check, it going to diminish over there from the surface. Yeah, whenever curing compound we will apply, it will get removed from there little bit. Then after 7 days and for 14 days, it will be, your curing efficiency will be of 65%, means curing whatever we are water is not there, because it will remove the membrane curing paint whatever we apply over there, it will get removed that compound. And here you can see the white and with curing compound and without curing compound. You can check over here. And again you can see how the application procedure I am talking about can be applied with a brush, and you can spray also. Okay, as we do in the canal, we generally spray because it will be of inclined surface, you can't reach, so generally we spray. And let the bleeding water dry, means at the top surface, when after finishing of your concrete surface, that the bleeding water should be get dry over your concrete surface. And after your PQC, when you are going your texturing and spraying, if you are going to see that paver machine, what concrete is PQC road, when they are creating, there will be one drum and two sprays will be there, and they will spray your this curing compound after you are just green concrete, as you are doing the your texturing of concrete. After that you will do your apply the curing compound. For structural members, we can't if you are going to cast your beam and column or girders, whenever you will remove the shuttering, that time you have to apply. And you have to stir whenever you are applying a curing compound for protection coating. You have to still first stir well it and make it homogeneous. Okay, and you can do water cured after 1 day by Hazen cloth also can be done. And this is one of the LNT lace first segment for third Mandavi bridge, Goa. And it came in Times of India, 8th of September 2016. Water conservation, what I am talking about, and we saved over here 10 crore liter of water, it came over there. So that's what I am talking about. Okay, you have to recommend the curing compound as your next generation uh, going to work at site and various places. So then again there are evaporation retarders are also there, it will help. It's like a curing compound. Generally in in our region, the temperature is very it will not go with the 20 to 40 degrees Celsius throughout the India, but like in Jammu Kashmir or other regions, okay, you can find out the temperature will be low. At that time, evaporation retarders will be used. And over here, one of you can see one diagram. This is the relative humidity, concrete temperature, and rate of evaporation. So generally, concrete temperature you can check from your thermometer over there, and you can mark your relative humidity of that particular day. Okay, that particular day temperature 22, then relative humidity, let's say 60, then it will come to concrete temperature. Generally it goes from 33 to 35 degrees Celsius. And then if you come down, you can find out the wind velocity for also for particular region. You can check through internet wind velocity, and you can find out the rate of evaporation. Here it's coming around 1.8 or 1.8. And from that rate of evaporation, you should know how much of curing compound you have to apply over there. Again, there are, for protection of your foundation coating, that is called coal tar epoxy based protection and curing membrane. Okay, generally it will be of black surface, generally will apply and will protect our foundation, because at the foundation level that will be, it is an extreme corrosive environment due to your sulfate and chemical attacks from the soil or the ingrazed environment over there, right? And again, these are now curing compound, and now I am coming to sealants. And sealants where we use generally, if you'll see very normal example I'll give, when we'll cut the groove in our PQC road, okay, and we'll cut it for the 300 depth of concrete PQC road. When we are cutting, we will cut it up to 100 or 50 depending what says, generally 75 we do. Then we will put the first we will apply the primer over there, okay, because we are putting the baker rod and there will be polysulfide sealant. Okay, so sealants, this is different surface, this is concrete surface, this is sealant, this is again concrete surface. So we have to require some of the primer to apply over there to stick over there. Okay, it should get stick over there. Due to that we use it. And the types of sealant depending upon silicon based sealant, polyurethane sealant based, acrylic based sealants, polysulfide. Generally, out of the all above, generally in the construction industry, polysulfide sealants are more popular in construction world. Okay, due to polysulfide sealants can be used in basements, glazing frames, ceiling joint, floors, roofs, external walls, claddings, and generally again you can use in bridges also. You can check, you can see it also whenever you visit, check that polysulfide poly. Again, the sealants comparison, when we are doing polysulfide sealant and polyurethane sealants are also been used. Okay, and that depends upon, again there are gun grade is also there, gun will come, okay, and pouring grade also there. I mean, you can pour it also, like that also comes. And over here you can see after the application in the, here you can observe, this is in a building. Okay, it makes the because why we are using over here, due to concrete is exposed to your environmental condition of the cycle of your temperatures over there changing. Day and night temperatures are different, and it will go from all the temperature cycle over there. Due to that there will be expansion and contraction. So due to that we also called it as a construction joint also, or expansion and contraction joint too, like depend. And it will be there in vertical, and depending upon the your the flow of traffic, okay, that is longitudinal joint, and the perpendicular to the flow of traffic there will be your transverse joint. So we will generally in the longitudinal joints you will check that this your material polysulfide sealants will be there. And over here see the gun will be used, and after the finishing surface of this polysulfide, two components and three components also there, it will be with the your this fillers, okay. And here the before and after applying you can see. And again we are going to start with your adhesives. Segment bonding adhesive generally we use for the precast. Your girders will be there, generally you for bridge construction, metro projects, generally we use it, okay, to establish a structural bond in between. So very simple thing I'll tell, generally the grade of concrete will be M60 or M80 over here. So this will be the M60 grade of concrete, this will be a M60 of grade of concrete when we are joining this. So this will be your critical section of crack whenever the load is going to be there. So this will be your critical section for your crack. So this joint should be, if this grade of concrete is there, this grade of concrete is there,
Understood.
above that it should, the grade of segment bonding adhesive should be above M60 grade of concrete, whatever adhesive you are using. So that's why you will
கண்ணம்மா
see the
தேக்க மரம் தோப்பு
grade of adhesives will use above 70 MPa, right? Then it should may, generally it will check with FIP standards, okay, and it provide high initial strength, because when you are using it, because at the time of construction it should not move out the girders over there, okay, because male and female joints will be there, but still it should be intact, and ultimate strength we should achieve. Resistance to your scratch, adhesion, abrasions. Then it should also resist to whatever the concrete can resist, acid, alkalis, solvents, oil. So it should resist. Then damping. So thixotropy solvent free. Surface preparation, whenever you have to prepare the surface. Okay, I'll show you over here. Here the segment, see here the segment is there. Okay, this segment, there you will find out not the joints. Wait. Here, see this segment is there. Right here, you will see the female and male joint. Remember one thing: this is for debonding agent. That is for your joining of the at the construction site. So these particular two segments we are going to, and as right hand side you can see the female joint, left hand side you can see the male joints. Okay, the male joints, when you are seeing it is in the trapezoidal section, and this angle should be of 10 degree. If that is not matched properly, the concrete will come out and it will not be clear. So why we are using segmental bonding over here? Okay, so we have to be mix this component. There will be, it will come in two component A mix should be properly. Then after 15 seconds, and this should be a 400 MP RMP, that mixer, whatever the electric mixer we are using at the site to mix this material at the site. Okay, the speed of your mixer should be of 400 RMP, and it will be applied like it will be of thick paste, like we will apply it at the surface of your girders. And then you can see where we are using this segment bonding adhesives. Here you can see these segments. This again, this is from Vijay Vinuman, where we work Sonipat. Then Afcons Nagpur. Then again, there will be, depending upon your temperature. Okay, depending upon temperature, you will find out the segment bonding blue below 25 degree and about 25 to 45 degree. It generally used here, maybe by mistake it is written 25 to 40 degree. Then there is called debonding agent. What happens whenever you are going to cast the girders at the site? The male and female joints will be created together. Two segments will be created. So that should be separated. So due to that, they have to apply the debonding agent or anti-bonding agent. It will at the face of your precast segment during the match casting. Generally, we'll do the match casting over there. Okay. Precast panel production and other application like break bond protection of the floor during construction, so that the plaster or paint can be removed easily. Over here, I explain. Here we generally apply these segments. We will cast. This will they give the unique ID for all the segment when they are launching the girders over at the site. So one female joint or other female joint, it will not be like that. Whatever they casted at their casting yard, precast casting yard, this particular segment, this is one of from our site. We were working in APCO, that is for Versova Bandra ceiling. It's going on in Mumbai. So from that side, this particular picture is. I only took this picture. Uh, then this is generally in a single component, ready to use. Just you have to apply at the concrete surface. It is water based and it will remove from there. Okay. Advantage: economical, high coverage rate over there, solvent free. Okay, easy application, ready to use, and good, no fire hazards problem over there. Then one more, I told you I'll more talk about corrosion later. Corrosion inhibitor solution. Now, because we are talking about durability concrete, I said performance based mixed design we are talking about. Now construction industry is purely talking about the lifespan of the structure service life. So it will be added in your concrete in a liquid form. Now recently I came to know there is a powder form also available in the market, but still it is not so popular, corrosion inhibitor solution of powder form. But yes, for sure, your liquid form is popular, and it will be added from 1 to 3%. And it is Chennai metros to all these metros, this all the government projects. Okay, from Pradhan Mantri Awas Yojana, every specification they are adding it for protection of your reinforcement. So this is the bipolar corrosion. What it does, I'll explain over here more. So how it means over here, action works over there. See, whenever your reinforcement is there, rebar. Generally, rebar, I'll talk it as Fe2 plus valency. Simple, I'll keep it simple. Fe2 plus valency, right? When Fe2 plus, if it is getting in contact with the moisture, that valency changes from Fe2 to Fe3 plus. Means volume expands, and that will create a crack at your concrete surface, and deterioration happens over there, because from corrosion initiation will start and it will deteriorate your concrete over there. And generally, whatever the failures of corrosions are there, it is due to failures of material. That indicates, that statistic indicate it is due to 40% of failure of structures, not due to, it is due to reinforcement. And whenever sulfate attacks the concrete or chloride attack, it will reinforcement corrosion will appear in coastal regions and other, wherever if it is getting in contact with your subsurface level, right? Again, the corrosions are, the types of corrosions are there. Inhibitor, again, corrosion inhibitors are inorganic and organic. Again, in organic also there are three types of corrosion inhibitors are available: anodic, cathodic, and mixed. And in organic, you will find out one adsorption corrosion inhibitor, generally calcium nitride based. Generally nowadays in the specification they mention that the nitride, it should be nitride free. Due to that, the mixed bipolar corrosions they are using recently. And as you can see, the anodic inhibitor calcium nitride based and bipolar nitride free, the comparison. Then if how you can check the corrosion inhibitor solution, which are they? So you, if you're going to check the pH 6.03 for calcium nitride and bipolar 8.17, you can identify your bipolar corrosion is nitride free. And the relative density, and again the chloride content in the both the cases is nil, but the best way to check is your pH over here. Again, this is the Coragard BP. It will be available in brownish liquid, mild. You, if you're going to order it, okay, you will find out a little bit of ammonia. This order will come over there. No irritation. pH will be 10.11. Specific gravity 1.05. Viscosity will be 11 second. Then at the accelerated corrosion test, we will apply the corrosion, layer over reinforcement. So one corrosion spot is you can do, as I explained, this Fe2 plus to Fe3 plus. You can check over here. Whenever the chloride is going to induce, this is your concrete side, there is anodic and cathodic reaction is going on over here, and this is the rust is going on, and it will be in the presence of your moisture and oxidation, then only this reaction going to take place inside your concrete surface. Okay. uh, Again, what the corrosion inhibitor is doing over there, see over here, this is the concrete surface, there will be passivating film is there. Okay, so this passivating film, how it is going, when you are going to add the corrosion inhibitor solution, the pH level of that concrete surface is going to maintain in your basic. It will not come to alkaline level. Whenever it will come to your from basic to alkaline or alkaline to basic, the pH from 13 to 8 or 9 side, that time this corrosion initiation will start. Without that, it cannot be damage your reinforcement. So due to that, the corrosion inhibitor solution will do that. It will not allow your concrete pH level to reduce. And this can be tested. This is one of the GIS Z1535 test. Your we'll keep our corrosion steel sample thick inside that, and we'll put it aluminum and rubber, and we'll allow it to remain for 18 hours at the ambient temperature, then allow it for water temperature below 1 degree Celsius. Observe the specimen for after 24 hours for any corrosion. Then effect of corrosion, optimum humidity for corrosion is 80%, expands 6 times of original, means it can expand and create your concrete deterioration over there. Okay, as you can see, the initiation and propagation, there is called the corrosion initiation. I recently been, I've been to one of the Ujjwal Kunte is there. He's consultant. He's the managing director of CQRA. He's the consultant. Okay, he's the consultant firm. That is the consultant firm. They are looking after the quality. Third party means there will be consultant means, see, one will be the client, one will be the contractor. Okay, and there will be subcontractor, whoever, and the third person will be this project management consultancy or quality. And nowadays the one more terms are coming, the quality, the quality assurance consultancy team is there. So they will check your quality parameters throughout the project, and and they will check what materials are you are taking care to maintain the quality parameters of your project. Okay. Again, you can see this is the particularly factors affecting your corrosion. This is a carbonation of concrete. Generally, this is a phenolphthalein indicator is there. Okay, so that you can check. And I said, see the pH 13 to pH 10 when it is going to initiate, that time you will find out the concrete is going to deteriorate. Here, this is exposed to your chloride attack and carbonation attack, and both the test factors affecting your corrosion. Again, that can be alkali aggregate reaction. You can see the surface how your cracks initiated over the concrete surface. Generally it is happen with the alkali hydroxide present in your aggregates. And the reactive aggregate means generally it will be high of silica oxide, and when it is going to react, okay, there will be the formation of gel will be there. Okay, with the calcium hydroxide what is present, it will be the crack will, it will propagate and it will create a crack from the aggregate, and it is noticeable over here at this concrete surface. So this should not happen. Again, it can leads to your corrosion. Again, impurities in your construction means whatever the water you are using, that also you have to check with the chlorides. Generally we will check the pH and all, but the thing is for plain concrete and RCC surface, you generally check this chloride percentage. You know what admixtures are also using, your whatever the admixtures are using, it should be chloride free also. It is also mentioned in your IS 9103. Okay. Factors affecting again the leakage, dampness, inadequacy of your concrete surface. Then it is again, your chloride threshold will be there. Chloride threshold, again it is like that your corrosion initiation is the chloride threshold point will be there. After that you can't use in your concrete surface the chloride threshold. Okay. And the purpose of again the adding corrugard over here to increase this threshold of your concrete. So why we are adding this bipolar corrosion over there. So generally the threshold value is 0.7 per kg per meter cube of concrete. Above that the chloride percentage cannot be, we cannot tolerate over there. Okay. Advantages will be nitrates free, compatible with other, again the whatever the admixture or whatever the material you are using in your concrete, it should be compatible. Whatever the conventional I'm talking about, no adverse effect on slump and compression or mechanical properties, we can say over here. Improves the durability because it is going to protect and lifespan of the structure. Okay. And also influences of your reinforcement corrosion. And it is going to corrosion protection from your chloride attack does not get consumed by cement hydration. It is not, it is going to be present over there dosage independent of anticipated of chloride level, because I told you 0.7 is our limit of your kg per meter cube of chloride in our concrete, so we can't increase above that. Again, this is in immersion test, you can see over the picture over here, and we are going to check 3 bottle. It is CPCI 1% and 3 without CPCI again nothing but your corrosion inhibitor solution will keep, and 1 with the water will keep, and then we'll calculate with the 534 W1 and W2 by DAT. And these are the specification. This is ASTM G109. This requires particularly year test particularly, and after a year test only we can conclude this. And here you can see this, we are also testing, and this particularly exposed to your concrete with the chloride solution over here. Sodium chloride solution will keep in this. Okay. And then we will expose this your reinforcement with the chloride attacks over there throughout, and that chloride will be checked over the concrete cover surface will keep over there. So again the RCPT with and without, you can see again here also it is going to reduce. I already explained this test, right? Where to use our corrosion inhibitor solution. Structures in sea water, for sure it is recommended. Power plants, bridge and flyovers, high-rise buildings, precast elements, tunnels and underground structures, retaining wall, industrial plants. And here you can see what the test we did with the steel sample with 1% of corrosion, bipolar tap water, steel sample with the tap water. Okay, that is without your corrosion initiation. Here you can see after 28 days how it is, corrosion without and with, how it is initiation. And you can see at the right side of image, just I think it's getting interchanged. This is without the corrosion, 1% of your corrugate bipolar corrosion. There is a just image got interchanged. It will create your corrosion. There will not be any corrosion if you are going to add this bipolar corrosion. Then there is one more, coatings are coming nowadays we are using. We will, if your, the it happened in the, because they are constructing at a very speed, so they have to buy the material at a very large scale, and they don't have, yards to keep. Those steel yards will not be there. Steel will be exposed to environment, and it will create a corrosion before, placing the reinforcement at the site. That time they have to use this particularly corrugate. It will be added in your cement. Okay, this is 16 bar. This is from one of the type. These are the instrument required: measuring jar, tape, notch, then trowel, then mechanical stirrer. And we will apply it. See, we'll remove first. We'll use your a metal cleaner, and we'll clean the metal throughout. Then after the metal cleaner, we will add our, see, remove the rust and all the things. And then we'll mix corrugate in OPC 0.5 to zero point 0.6, or your one ratio. Okay, solution 0.5 will be your inhibitor solution, and zero point 0.6 will be your cement will be added in your, or zero point 0.5 to 1 cement, means 500 gram of corrugate and 1% of your cement will be added in the paste over there. What we are going to apply, we are preparing it like, paste or paint, you can say. And that will be added, because it's been happened. And this is from one of the site from Shapoji, where they found out this. I've been to witness that. Here, see, after applying, so corrosion initiation will not be applied. This is the coverage area, and this is again, and you can use the ponding method also. You can pond, and you can do that. Then about microsilica, this also makes, their microsilica, if you see, nowadays it's being used in construction industry a lot. It is available in your powder form, condensed form, slurry silica form. Okay, generally the microsilica will be available in the grades. Okay, from it depending upon the silica content in your powder form. It is available in the classification of 85D, 90D, 92D. But in construction industry, they will say above 90% of silica and below 90% of silica. Okay, and depending upon the grade of concrete we recommend. And this is our product. It's used for high performance concrete, self compacting concrete. It can be used for your blast furnace, troughs, runners, and then your ceramic construction, clean, right, parking, bridge decks, everything. See, whenever we are adding this supplementary cementitious material in our concrete, because this is also an chemical additive, so I'll consider it as cementitious. So fly ash, whenever you are going to add in a concrete, it's going to improve your workability over there, let it be any grade. And if you are going to add, ground granulous blast furnace slag, it's going to improve your later strength, means the 7 days strength, it is not going to contribute. And similarly, fly ash is also not going to contribute over here to your mechanical or compressive strength. But fly ash strength will be generally can be checked at 56 or 90 days, because it's going to be, late, going to be after 28 days strength only it is going to improve. Okay, because gel formation will be after 28 days strength. But in GGBS it starts from 7 to 14 or 14 to 28 days strength. I'll say 14 to 28 is the better thing to say, improves the later strength over here. Metacolins improve early strength, as it is similar to your microsilica. And as this is from my own work. Okay, I use this from macro and nano. I am saying macro, micro and nano level. So you can see over here, the particle size distribution from right to left, it's going finer and finer. and it's OPC, GGBS, fly ash, microcalcium kaolin, metakaolin, microsilica, nano clay, and nanosilica. Generally, the nano will be available in single. You can see that there is a line directly. A line is coming, right? So that's of 79 nanometer, and nano clay is of 1 nanometer. It's like that. It will be available. Okay. Then shuttering oils will be used. I'll skip this shuttering oil because I'm having. What are the new product development and future ready products? What we are talking. See, nowadays 3D printing concrete and 3D volumetric printing or nano based concretes are required. So that required again the advanced chemical. You can't you have to use VMA over here in a powder form, then polycarboxylic based ether purely you have to use in this particular, because it depends upon buildability and printability, and basically it's about yield stress versus your you have to check their yield stress. You have to check because it should be good in shear strength when you are placing one layer. So above layer it should come, then again above layer, and before the first layer drying, so above layer should come, and it should be in a thickness of your, that thickness should be maintained. And I'll say if we already did this before also, here you can see here, see printing, how the printing is coming. There are particular there are good startups are there in India. Many are working from the IITs in 3D printing, and I've been associated in LNT too. I've been associated in CBRE for this particular 3D printing, and they are doing with the alkali activated concrete. They are not using this conventional concrete over there. Okay, and because of that they are using advanced chemicals and tailor made chemicals what we are giving to them. And I said to you, so they have to add two chemicals over there, not only one admixture they have to add over there. And you can see your 3D products are also in the range over there: superflow, set fast, e-guard. From the environment you have to guard then it should self cure also. Then this is constructed by it is at Bangalore they constructed. Again it is by LNT also building the 4-story building of for border road organization. They are going to build up to 4-story of 3D printing. Already it is going on, maybe at the completion stage. And again there is MyCob is there from IIT Gandhinagar. Then there is Twasta is there from your IIT Chennai. They are building. There are many other than, I think, from Kharagpur also, one of the startup they are doing the this particular 3D printing work. And now it is in, because it's going to be mainly modernization and automation of the construction industry. And again the graphene based concrete is also one of the project. He's our MD who is studying graphic engineering. Very high strength and high durable, but due to graphene is uh, not cheaper material, so due to that, depending upon requirement only, we can suggest that. Again there is called nowadays people are demanding ki we don't want to pour, means go for a water curing or curing compound also. So it's called internal curing method. It's the modern twist of just you have to add one self curing compound in this, and no need to add water at all. And what will happen, there will be saturated one chemical will be there, self absorbent polymer will be there. It will allow the water internally, it will keep that water inside the concrete, and it will not allow the water to come out from your concrete. Evaporation losses it will stop. And this depending upon it will largely auto shrinkage, many things are there already what we talk about curing compound. So here again this is underwater curing. You can see over here, you can see one of the video what we did in our lab. And I'm saying of underwater concreting with the admixtures, and even see with after adding the admixtures, okay, they are pouring it in the in the inside the water, and you can see there is no reaction with your concrete at all. Then there is 3D volumetric construction. There are nowadays, Home Mission is there. Then Magic Pots are there. These are the construction companies. They are doing it. And we also did. I'm doing the one of the work with IIIT for this particularly 3D volumetric concrete is going on, and one of the PhD also working with me in this particularly 3D volumetric concrete. And again, the nano base. See, nano means now we are talking not from the test cylinder, coarse aggregate, fine aggregate, cement clinker grains, gel. We already then CSH colloiders. Now we are in the molecule level. That's what we are talking about, the nano materials over here in the cement industry. And it started already. My macro is in the used in the construction industry, but now they are going to be nano engineered soon, and maybe it started, and you are going to see that revolution of nano based concrete. And then again, ultra high performance concrete, UHPC, one of the example. I'm not going to explain this particularly. I'll be more explaining, this will be morely available to you, but I'll explain one of the project what I am working on. That is ultra high performance SDPL, if you know, Shinde Developer Precast Limited, Pune. And they casted 120-meter of span with the ultra high performance with the grade of 150 concrete. What they are doing over there, they are reducing the section, thickness, so that overall your dead load of your particular segment get reduced, so you can go with the longer span and you can apply over there, and you can go with the higher span, and the load will be less. And they are using nowadays, they are try to ultra high performance lightweight also nowadays been recommended. And it's almost work as a what our steel elastic modulus of elasticity, similar to that it works. And then there is called geopolymer and alkali activated concrete. I did my PhD. This particularly, I did my microstructure. I'll see my total microstructure of alkali activated fly ash GGBS metaquilline binder systems, setting at ambient temperature. That is my PhD topic. And whenever there is a geopolymer or alkali activated is there, I'll explain to you there is a difference. What is the differences? Geopolymer means there will be 3D formulation, poly chains will be there, and there is only a formation of sodium aluminosilicate hydride, and it requires heat curing. What alkali activated concrete will be there? There will be calcium silicate hydrate, there will be calcium aluminosilicate hydrate, there will be sodium aluminosilicate hydrate. It is the combination of gels. But in geopolymer, it will not happen. Means if you are going with the fly ash, and if you are using sodium hydroxide and sodium silicate, with that, if you are going to use, that time you are going with the means that is geopolymer concrete. If you are going to with fly ash GGBS, that time it is alkali activated concrete. Again, it's again in demand. They are saying go with the bendable concrete. So this also requires for bending of high durability, ductability, strength, resistance to crack we require. So again, we require the bendability of concrete. Then recycled concrete is again, and one of the alternative in this also. Again, you require admixtures, okay, that can be adhere, because there will be adhere mortar will be there. You have to remove that adhere mortar, then you have to make your aggregate to the quality parameter to your virgin aggregate. Okay, so virgin aggregate, whatever you are using over there, that you have to constrain and make it less energy than mining, right? Whatever the mining industry, or you make it powder, or you can make it sand or aggregate what you are using. uh, Again, self cure internal curing compound, I explained this is also Christa's shake. I'll not take that much. And maybe we can discuss little more. Then this is one of the project I did with government, a proposal of new method for Parnan Road. It is called Village Field Road. It's going from inside, and this concrete, I created the road over there, and it's totally there is no, because within a 1 kilometer of span they required. They given us the cost of 27 lakhs. Okay, and it's been submitted to Mantralaya, and it can be open to traffic within 1 or 2 hours also, because there will not be high traffic. It is very low traffic area it will be. And it's without a cement is not at all there. Okay, It's only a waste material over there with what we casted. And as we talk about Liverpool University, Dr. Anna Brass, she's been over our lab, and we work with her is of bio additive self filling concrete. What we are working with her. Then this is again nanotechnology in internal curing. I explained this already. And one more segment is, nowadays we are coming with this precast panels are there, precast panels. So this is also required your this particularly one of the um, site photos only in construction industry photo. I've been visited over there. They are like they make the slurry with the cement 50%, then lime, then there will be fly ash together, and they will pour in this particular panel up to half only, and another half it should be expand, means it should the your slurry should expand and fill your whole mold, and then this particular segment is created. The precast panels will be created, and it is generally from your aluminum powder, that is called your AC aluminum foam, like it will come up. And I think I'm done for today, and thank you.
Thank you, sir. Thank you so much for giving presentation today. It was wonderful. So next, so today we discussed about different types of futuristic construction materials. First, we started with the Crystacrete, AC Crystacrete, and we discussed about the durability versus permeability plot. And then we discussed about the concrete service life, and we have seen different applications, advantages of this material, and we have seen all the futuristic different materials which are coming, upcoming. That we are going to use, like ultra high performance geopolymers and the bendable concrete, and we have seen the nano based concrete, and we have seen the different properties. So now I would like to request Dr. Praveen to read out the questions to Dr. Muralidhar.
Thank you. Thank you, Lakshmi. Uh, Thank you, Dr. Murali, for giving us such a broad and a complete overview of the different construction chemicals that can be used as a futuristic perspective for the rapid construction in the industries. So let me start with few questions. One of the participants has asked, the construction chemicals which you have talked about, because you have covered different type of admixtures, retarders. So is there any type of particular admixture which you are trying to promote, especially for the construction of high performance concrete? What type of retarders or what type of admixtures we should go for? Is there any
Then
specific?
yes. Practices that is polycarboxylic based ethers. Okay, if you
Okay,
are going to buy from any I said competitors too, let's say Fosroxica, BSFs are they are there, so they are going to provide you PCE only, and the retarders are depending upon what's requirement. High performance concrete when you are suggesting, so there will be high content of your cementitious material, maybe around 600 to 700
okay.
kg per meter cube. So means the particle is having high surface area over there. So and
Hmm.
it will absorb water too much. So and if it and you require high performance concrete, means your workability will be at the higher side. Means there will be flow
Right.
only. Okay, so the snub
Hmm.
requirement will be 600 to 700 after 3 hours of flow required, 600 to 700 So and after that maybe after one day you require 40 MPa of strength, like that maybe
Right.
it's required over there for of one day strength. We are not talking about 3 7 and 28 days. Now they are talking about one day strength, and at the few places they are doing accelerated curing test for of 28 days strength. So we'll get the prediction of our compressive strength at par, means we are not going to wait up to 28 days, and that's the construction industry demand. So for sure the high performance concrete, there will be deformer, there will not be any air entertainment or air entertaining
Right.
agent. Okay, because it will create, it will not allow the strength, it will affect the strength properties too much. So air content will be below your 2%, and maybe it will come up to 1%, like that, then only you can achieve that strength. And the next part will be, there will be accelerators will be there, and again the accelerator, the best accelerator is calcium chloride. Okay, but
Okay.
as I said, the chloride threshold value is there, right? So you can't increase that, because why? That will initiate the corrosion at the concrete, so you can't add that particularly
Right. And
in your concrete.
especially in case of, let's say there is a mass concreting, for example, in case of the dams, right?
Yes, yes.
So, so out of the different types of admixtures, as you correctly mentioned, retarding agents, there will be accelerating agents, there will be water reducers. So
And
what
slump
type of
retention.
admixtures? Yes. So what type of admixtures people are using, especially in case of a mass concreting, so that
Mass
we can
concreting.
get for the mass concreting, for example, dams
Yes,
in such a
yes,
case.
yes. I'll come for a dam example. Now, for a dam example, if you will see ligno base, ligno, what will do? It is
Hmm.
not allowing you, it after 1 hour or after 3 hours. It is going to be presence over there, and their
Okay.
grade of concrete is hardly M15, M20. The grade of concrete is not higher, but the heat dissipation because of heat of hydration,
Hmm.
okay, it will create a
Understood.
problem, means thermal problem. So we have to maintain that shrinkage thing over there, means it should not shrink, and it will not create a crack at your concrete over there. And you
Hmm.
will generally use, ice will be used over there, that is the practice.
Okay.
Because of that heat dissipation, or you will, go with the cold water pipe inside the mass concreting, to not that heat of hydration should be get controlled. And also the aggregates will be, make it, they will keep it in a, somewhere in a particular lower temperature, very lower temperature, and bring it, and then they do the concreting. Not only
Okay.
with the admixture we can control this much things, but what we do, we will delay the reaction time, but we can't delay, because they have to construct. As you know, the cement will say initial setting time will be 30 minutes, final setting time will be your 600 minutes or 10 hours. But if I'm this 30 minutes of that particular OPC 43 or 53 grade, if I am going to
Okay.
delete, okay, so 1 hour, 2 hour, 3 hour, I have to check key up to what level that heat of hydration, that heat is coming out. So that's what the trial basis of admixture we have to add, and will increase the your setting time, will slow it down.
Right.
With that
Okay.
means there will be water reduction will be less, means I think negligible. Slump retention will be there,
Negligible.
means
Hmm. Hmm.
slump retarder is there na, so it will be more over
Right.
in that particular case. Accelerator will be zero, we don't require any accelerator, because
Okay.
accelerate we can't
Okay.
do over there. So it is
Hmm.
like that.
So
There will not be
depending
any
upon the type,
deformer, any deformer
yes.
also will not be there.
Okay. So depending upon the type of construction and depending upon the kind of environment in which you are constructing, depending on the type of structure also, the different type of admixtures what we are going to use,
Yes,
that
yes,
will vary. That will
yes,
vary.
yes,
Okay.
yes.
Okay. So one participant has asked a very fundamental question. When we are using any type of an admixture, is we are going for a strength or only it is for the durability perspective?
As I said, mean strength Fm is equal to FCK plus 1.65 into standard deviation.
Deviation.
Okay, there is no durability, means time. Durability is means time.
Hmm.
Okay, so
Right.
we are not using any time in that particular equation. So now what happens? The client requirement, as he said. So let's say bullet train, I am said from Ahmedabad to Mumbai, they are constructing. Now their criteria is durability. Also their criteria is strength. Strength cannot be, means we can't compensate on strength parameters. If strength is
Right.
going to reduce, means your concrete is permeable, means water, or I
Hmm.
say transport properties, I say generally whatever get transported inside of your concrete.
Right.
Okay, so durability is for sure getting to reduce. So whatever the material you add of your 1,000 per rupees kg, or 1,500 rupees per kg also, that not going to matter at all over there.
Okay. Okay. Is there any specific disadvantage of using these kind of admixtures which you want to highlight?
Yes, I already said to you what happens at few site. I'll not particularly name it. Let's say crystalline acid. So
Hmm.
the usage, you should know how to use it, because what they did,
Right.
they mixed fine aggregate with coarse aggregate. This is our mixture. The starting step at the site will be this. Okay, we'll wait the first your sand, and we will wait coarse aggregate 10 coarse aggregate metal 1, metal 2, we also say 10 20 then your fine aggregate. Nowadays it's only crushed sand, natural sand is not being used in the construction industry nowadays. They will mix it, right? Then they added crystacrete, crystalline durability admixture. So this crystalline will be stick to your aggregates.
Ah.
Okay. So now they added cement. Then they added your water and admixture. So what happens?
Hmm.
The effect of crystalline will be over your aggregate surface, and
Aggregate.
there will it is going to stick, and you are not going to find out the self healing and durability perspective in that particular
Okay.
case. It is going to reduce. So like that, this is one of the case I said. So maybe you can understand. Similarly,
Right. Right.
admixtures will be, if you are, let's say 1% you added your admixture in your concrete, and you not achieved your slump. If you not
Hmm.
achieved your slump after 3 hours, you required, let's say 100 of slump, but you not achieved it. Then what you did redosing of admixture. So what will happen when you are
Okay.
going to redosing of admixture? It will act as a retarder, and you are not your
Ah.
concrete is not going to set at all.
Okay.
So these are the cases,
Okay.
and means
So the
it
so
is
the
not about
optimum
the yeah, it is about the usage, proper usage of
usage. Right.
chemicals.
So using the proper protocol as per the standards, and also the optimum quantity of the dosage, what is required to achieve the great
Right.
strength and the durability perspective. Okay.
Yes.
Uh, Although you have already mentioned, is there any effect on the water cement ratio when we mix crystalline waterproofing admixture? Usually,
No,
people
no.
usually
Why?
people say that for a concrete, the water cement ratio of 0.48 to 0.52 is preferable. So suppose if I am using an admixture, you said that 20 to 30% of the water requirement is already been reduced, right? In one of your slides. So what is the effect on water cement ratio when we are using such kind of an advanced
One,
admixture?
yeah. One is crystalline durability and enhancing admixture that is added in a powder form. It is 0.8% to 1%. I
Point.
said generally,
Okay.
generally our product what we are giving, it is of 0.8%. Okay, of
Okay.
cementatious means cement plus GGBS cement plus microsilica, whatever the composition of mixed design is over there.
Hmm.
Now, admixture means super plasticizer if we are talking about. So,
Yes.
water cement ratio, let's say 0.4 is there. So, it is going to
Hmm.
reduce, let's say, to 0.36 or 0.37. So, if that is going to reduce, what you are going to achieve over there? For sure, your compressors, because water you reduced over here, it is directly proportional to your compressor strength, and strength is
Strength of
going
the
to
concrete.
increase. Simple.
Okay. So
And
that is
there
the
will be
that is the
more gel formations, calcium silicate gel formations will be there. Due to that only
okay.
you are going to get that increase in strength.
So as you have already pointed out, that was the follow-up question. Is there any significant change in the compressive strength of concrete when we go for this crystalline waterproofing admixtures?
No, it will going to increase
It,
up to,
it is going to
yeah,
increase.
yes, it's going to
Okay.
increase from 3 to 5%. I'm
3 to
not saying
5%.
yes,
Okay.
slightly increase, not significant increase you are going to find over there.
Okay. And since these admixtures are used for preparation of the concrete, is there any specific type of cement that is being used in
No, it
order to get
is.
the better quality results?
No, not like that. Any brand, any type of cement, like let's say I said to you, you can go with the ordinary
OPC or
Portland cement,
PPC, any
PPC,
type?
Portland Pozzolana cement. Let's say you are
Okay.
going OPC, and if you are working on any research project, let's say agro-based waste, or let's
Hmm.
say you are going for, let's say, alkali activated or geopolymer concrete. Also, I am saying because it required, calcium over there. If calcium is available with the moisture content, that crystal formation will
Okay.
going to happen, and it is going to self heal over there, and
Okay.
it's going to
Okay.
increase your durability.
And for
And
these admixtures,
I already, maybe that my journal is going to come. I already worked on that
okay.
manuscript,
Okay.
and maybe you will find out within 1 or 2 months.
Sure.
Maybe you'll find out it online. And with agro also, I'm working on. And
Okay.
yes, today only I'm discussing with one of the MTech student from MIT Manipal Institute, where
Okay.
I did my PhD. So he's going to come within next week.
Right.
So we are working with
Okay.
that bio additives and self healing only. And I
Okay.
said that Anna Brass, she works more on bio additives. So she's also
Okay.
working from one of the PhD student from PNIT. Also, they are working with this particular bio additives. So there are self-healing products are there, that is called MCPM is also one of the products, self-healing product, that is micro
Okay.
capsulated phase changing material. It will be
Hmm.
available inside the concrete, and it will get open after, if there will be any cracks, and it will open up. So like that also, bio additives, these are bio additives available in the market, so you can use it for research purpose.
Okay. Uh, let's go to the next question. The participant is asking, as you have mentioned that for these admixtures, 0.8%, 0.9% in terms of proportion which we are going to use, is there any specific recommendation or the guideline from any standards which says that in what proportion we should use admixtures in the concrete? Or depends on the company to company or the manufacturing unit, it will change based on their research product? Dr. Murli? May I audible?
Sir, yes, sir, audible, sir.
I think his
Some
network is,
issue with the network.
yeah, his screen got freezed.
Yes, sir, yes, sir.
Dr. Murli, are you able to hear me out? Maybe he need to reconnect. Let let me call him. Yes, I'm extremely sorry for the technical glitch. The speaker is rejoining again.
Okay, sir.
Yes, yeah, sorry. Yeah, the question was in what proportion we should use these admixtures for concrete, because there are several companies which are making these kind of admixtures. Dr. Murli, are you able to hear me? Dr. Murli? It's not audible? Please unshare your screen. Your screen is still visible. I think it still got stuck. We can see your presentation. I can see you, but your voice is not audible.
Sir, no, sir, we can't hear you.
Right now?
Yes, sir, we can hear you.
Yes, yes.
Yes, now it's coming. Yeah. The next question was, you said you already mentioned that these admixtures has to be added in certain optimum quantity, right? Let's say 0.8%, 0.9%, depending on the different kind of admixtures. So is there any specific recommendation or the guidelines by the different standards which says that in what proportion we should use these admixtures for concrete? Is there any
See,
lower limit or is there any upper limit?
yes. See, always whenever we develop a product, okay,
Hmm.
so there will be an R&D.
Right.
So we generally, whatever the dosage is recommended by manufacturers or let's say any practitioners. So we use, let's say, we develop the material, then we will start with point 0.6, point 0.7, point 0.8, point 0.9. As you know, how we do the cement compatibility test of Marshcone
Right.
test, if you know. So what we check, admixture we will add, and we will check up to what optimum dosage percentage, 1.5,
Right.
1.6, like that it will come. After that, you can't add admixture. It is not going to help you for your mechanical properties or
True.
your
Hmm.
workability. So let's say above 1 point, why 1.5 is restricted nowadays? Because the chemical is nowadays, it's that much advanced ki up to 1.5 for sure you are going to get your optimum results.
Hmm. Okay. Okay. Especially in the large projects, how efficient these curing compounds are. You talked about the curing compounds, right?
Yes.
Uh, for the application, and what is the cost implication of these curing compounds?
Uh, I'll say about the latest practice, okay,
Okay,
as suggested by MORT, Ministry of Road and Transport. So and IRC, Indian Road Congress. So for the
Congress.
PQC road, nowadays expressway, they are going with generally M40 grade of concrete. M40 grade of concrete when they are making over there, okay. So when they are going to make M40 grade of concrete, so what will be their target strength? For M40, it will be as per us 1.65 into 5. That will be standard deviation we'll consider, and that will come to
Hmm.
48.25. But
Okay.
now
Hmm.
the code recommends it should be plus 4 MPa. So it goes to 52 MPa. Now,
52
with
MP.
so they have to increase little bit of cement content because to achieve 50
Hmm.
2 MPa of M40 grade of concrete. As we know, if you know the quality assurances, if you know, there will be FCK minus 3, FCK plus minus 4 MPa or plus 0.85, 0.0825 standard deviation plus minus, or
Hmm.
15% of individual variations of grade of concrete.
Okay.
Right? This is the criteria of the quality assurance of the concrete prospect. Now, over there, what we are saying, 52 MPa you are have to achieve. So when you are adding this particular additive over there, okay,
That
so
curing
huh,
compound. Hmm.
let's say curing compound. So why we added? Because at least it should achieve 48 MPa. So
Hmm.
they are targeting 52. So generally it should be above 52, 53, 54. So
Okay.
curing compressive strength will come boils down to 3 to 4 MPa less, because it above 90% is our criteria of curing compound. Okay, so we'll
Right.
use the curing compound. We are saving water, but we are not compensating on compressive strength, because 48 MPa it will achieve. It is not going to achieve 52 or
So,
53.
so it is not always recommended that these curing of compounds has to be added externally to the surface, or sometimes it is already taken care while the preparation of the concrete itself.
Yes, it can be. That is called self-internal curing compound, as I talked
Okay.
about.
Okay.
That's the
It's a,
latest
a special category.
innovation.
Okay.
Yes, but eh, practices, it will be applied over the surface when we will remove the shuttering, or
Shuttering.
when
Yes.
laying the concrete with your paver machines. You will apply at the green surface of the concrete.
Right. Right. You talked about this Hessian cloth. What
Has
exactly it is?
it will be,
Is it a specific type of a
no,
jute
it
material
will
or
be cotton, just cotton cloth, whitish. It will be.
cotton?
You can
Okay.
just you can. So it will be layer over concrete. It will not allow the water to evaporate. Let it be
Evaporate.
any cloth.
Okay.
So the what
Hmm.
concrete needs require full hydration of your cement. So it requires water over there. So for water over there,
Hmm.
if it requires, so we have to just maintain. See, very simple. The concrete road surface is this. Okay, this much of concrete is over there. So from the bottom to the top, the heat will release from the top of the surface, right? Top of the concrete surface. So from the top of the concrete surface, so heat will be removed. So always you will remember ki here the heat is higher side compared to the lower one.
Hmm.
So heat depends, that
True.
the dissipation is happen at the top surface, and you will find out shrinkage at the top layer, not at the bottom layer or the middle layer, because heat is going to evaporate from the top layer. So there will be
Hmm.
shrinkage, and you will find out the cracks at the top layer of the concrete. So
Okay.
what we are doing when we are applying this compound or cloth
Hessian.
or water also, let's say water also, so you are maintaining the temperature of the concrete with that
Right.
heat
Right.
hydration, and that you are compensating, means you are not allowing
Serving the
the
purpose.
concrete shrinkage over there.
Okay. Uh, you talked about this resin-based compounds, right? These resin-based compounds are usually expensive, we presume, and
Yes.
especially in India, where, yes, and especially in India, where the cost of construction is among the top priorities. Is it possible for resin-based compounds to become popular choice in the future, or still in the current ongoing projects, people are using this compounds?
People are using it.
People are using it. Okay.
Using it because, for example, let's say concrete piers, if you say this concrete piers of your metro sections. Okay,
Hmm.
so what they are asking, I'm not going to apply paint. I'm not going to apply
Okay.
paint. Give me a curing compound, I will apply. It will be there always. And
Okay.
yes, it will be
Which will
like a
serve
paint,
both the
and the
purposes.
carbonation coating too. So they are asking like
Okay.
that. So it's the demand, and we have to create it.
Okay. Okay. Uh, you just highlighted about this bendable concrete. One of the participant has a curious question where she has asked, what are the factors that need to be considered for a bendable concrete? Is there any specific points which you want to highlight?
See, particularly it will be fiber based. Okay, the fiber content will be high over there. But again, you have to, your concrete is the your brittle material. Okay, so in that we have to add, like, graphing, where the graphings come in the picture. So generally you will see
Right.
the bendable concrete will have that. So due to that, re- recently you will not see that the bendable concrete is at the par of, use in the construction industry. Let it be any zones. But as you are all from, earthquake sectors, so what's the, I'm talking about damping and other things. So one of the
Yes, the
that
deformation
will
capabilities of the
give the
structural components.
flexibility. Okay, with that
Hmm.
particular vibration, okay, that frequency, if it is can withstand. Okay, so it will be very beneficial to of the construction
So,
industry.
as per your knowledge, is there any application which has already been done at the construction where this bendable concrete
Tangible,
approach has been proposed?
till now means in particularly my
Is it already existing? Is it
yes, yes,
already
it is,
existing
it
in
is, it is,
any
it
of
is.
these structural components? It
Yes,
is.
not in
Okay.
India, but they used, I think, in Europe.
Okay. So,
I
is
not
it for the
remember.
pavements? Is it
No,
for the
not
pavements
payment, not payment.
or
It's
for
housing.
buildings also?
Yes, yes, housing.
Housing.
Yeah,
Okay.
house sector. See, another thing is nowadays the I not talk about more about joints also maybe in any other session, but the joint also, like I'll talk about one of the project, it's going on total 100 1000 means I'm talking about the 1000 of your this span precast, that is of big span of your
Okay.
bridges. It is constructed in Malaysia, okay, and it is constructed by them, UCM, the construction firm from Malaysia, and one of the construction is from China. Okay,
Okay.
there what the dam they are using over there, they are using the what happens over there at the mid of the section. Okay, it is the high sea level is over high, and there is going to be earthquake also, there going to be wind blow at your cable straight bridge. Okay,
Right.
so in that particular time what the damper they are using, okay, as you know, if we are going to, if you as you all are know about the earthquake, as you will go higher, okay, so your vibration can go increase depending upon your dead load where
Yes.
it
The
is, right?
amplitude
It's
and the
like a
frequency
cantilever we can
increases.
say,
Right.
like a cantilever we can say, so where the load is now, what they did, they already piled, work is started, construction is started, and they find out ki at the sea level we are going to be a very high wind and it cannot resist the
Okay.
earthquake over there. So one of the professors only, I don't remember his name, I think from he is also from Malaysia only. So he designed one of the elastomeric damper over there.
Okay.
He designed, and it is layered, one layer of elasticity and one brittle material elastic, and he created one elastomeric damper which can, if it is going to be earthquake is going to come in horizontal or let's say in other direction too, of x and y, both the direction it can come, right? So it can withstand that particular, so depending
Okay.
upon that only, I think the bendable concrete is also depend where we can say there are 5 zones, right? At which zone we are going to imply that, so maybe
Okay.
that will be the question, and where we
Hmm.
are, I'll say that should be used, because see conventional material should be also, when we are saying ki housing it should be for all, from
Right.
economics to your higher
Hmm.
whoever we say your economic zones also should be comply, because when you will see Pradhan Mantri Awas Yojana, housing for all, it is housing for all.
Right.
So
Right.
that bendable material should be cost effective too, that time I will say ki
True.
you have to use it.
Agree. Okay. Okay. So thank you. Thank you, Dr. Murli, for your precious time and for
Yeah.
clarifying all the queries and the doubts of
Yes,
our
yes,
participants.
yes,
So over to the team. Yes.
yes.
Yes, sir. Thank you, sir. I
Thank
also want to thank all the participants for making this event a grand success. I hope all your queries are clarified. Now, I would like to call upon Ms. Shambhavi to address the vote of thanks.
Hello everyone. I hope I'm audible.
Yes.
I'm
Yes. You are.
Shambhavi Trivedi, pursuing MTech in Computer Aided Structure Engineering at IIIT Hyderabad. It is my extreme honor and privilege to propose the vote of thanks on behalf of the IIIT Hyderabad student chapter for this occasion. First and foremost, I would like to thank our guest speaker, Dr. Muralidhar Kamath. Despite his busy schedule, has found it time to grace today's webinar. Thank you, sir. Thank you so much for your time. And sharing such an sharing such a valuable knowledge on the topic of futuristic construction, chemicals for rapidly growing construction industry, which is a great interest to the structural engineers, research scholars, and to industry people. So the insights we received today about the futuristic construction chemicals such as crystalline admixtures, polymer admixtures, sealants, the corrosion inhibitor solutions, and the new products that you also shared with us, which were self-compacting concrete, bending concretes, which were very interesting to know and understand. They were very fascinating to us at the same time. These topics definitely helped us to better understand the growing construction industry. I would like to express a heartfelt gratitude to our faculty advisor, Dr. Praveen Kumar Venkatrao, for his valuable guidance and timely suggestion throughout this process. My sincere thanks to Mr. Shrikant, IT team, Mrs. Babita, and Mrs. Grace, our design team, for providing all the logistic supports, help, and assistance. I also thank all those who have directly and indirectly helped us to make this event successful. My special thanks to all the participants for their active participation and enormous cooperation. Last but not the least, I also want to acknowledge the effort, support, and cooperation of my entire team for making this webinar a successful event. Finally, I want to end this program by extending my sincere gratitude to all who are on this journey with us and making this event a grand success. It was indeed a great pleasure to have you all today. This concludes our webinar. Thank you all for attending. We hope that as we have, you also have learned and enjoyed this webinar. Thank you so much, everybody.
And it was indeed a very comprehensive and a very detailed presentation, Dr. Murli. I really appreciate for your time and thank you. Thank you so much.
Thank you.
Okay.
Thank you so much, sir.
Thank you all.
Thank you, sir.
ले गया